Good day to you. This is Anagalactic on our second presentation on this Tuesday, March 25th. The reason for this second video is because yesterday's video on conjugality has gotten an extraordinary number of views. And therefore, I'm forced to respond to that sudden influx of attention towards conjugality. Because of the nature of the sequence that I'm in, it's a formal paper production sequence. I've never seen this done because I'm not sure how likely it would be to happen, but it's happened to me that I know that I'm in a discovery sequence, and therefore the production of my overdue paper on this new geometry has been delayed for over a year, because I've been inundated with new discoveries. This goes in all directions. Now, all of this sounds pretentious, pompous, and precocious. So, because I'm getting attention for the summary lecture on conjugality, right now I want to elaborate on that conjugality, because it's highly suggestive. What do I mean by conjugality? I only gave an overview. In science, you do need to bracket your subject somehow, either implicitly or in the exchange or delivery sequence. You have to establish the basis of what you're talking about. What diving board are you jumping off of? Because there are many. Now, in this case, what we're talking about when I say conjugality, which video summary has gotten to me an enormous amount of attention. It's about 50 views in just 24 hours. That's enormous. I've produced well over 900 videos now in under 3 years, and I rarely get that kind of response. We're talking about maybe a dozen or less times that I've gotten 50 views in 24 hours. But you see, there are some other statistics that I have to regard. There were no likes. Now, I don't actually solicit either likes or subscribes. It's not part of my strategy, my approach to producing scientific videos. When you get a like, I can tell you it's really quite a boost. You feel good when you get a like. I'm not sure that I'm interpreting this correctly. The necessity right now to explain conjugality is in my mind at the forefront of what I'm doing currently at this moment. So what do I mean by conjugality in terms of a monopole? The next lecture that I released earlier today, based on some sudden scientific insight from my research period this morning, I reviewed my knowledge of the monopole, which is predicted by Dirac. I should say it's interpreted by Dirac should the monopole be discovered, which it has not been. Now, there are diagrams, which I went through in the last lecture, of what a monopole would look like. But in the case of electromagnetism, you're talking about two monopolar possibilities, because electromagnetism is two conjugal forces. And there's that word again, conjugal. All right. So to keep this brief and concise, but elaborate enough so you know what conjugality is, that's a mathematical term. Conjugality refers to a cross-multiplicative system, because you're talking about a two-component number system. So when you say conjugality, usually, or I would say always today, you're referring to complex numbers, really the complex plane, and in the XY coordinate system, the y-axis has a different metric than the normal linear spatial separation axis that we call x, the horizontal axis. But in planar space, you then have to define what is the vertical metric. In linear systematic space, what we would call 2D planar geometry. There's a mathematics for that, but it relies on orthogonality in the plane. All right, so far so good. When you're in the plane, you have two numbers, x and y. When you're in 1D space, you only have one number. That's called a one-componency number system, and it forms the basis of additive mathematics to get distance. And I've covered that so many times. If you don't understand perfectly what I said, you don't really need to worry. Unless you are worried, you can go back and see some of my lectures. Leave a comment. Also, I haven't gotten any comments. A scientist expects comments. If you're not getting comments, there's something wrong at one end or the other. You have to ask questions in science in order to complete your understanding of what's being said. Unless you perfectly understand it, which is almost never the case in a teaching situation at this level. Because I'm attempting to introduce another geometry, well, though you would want to understand what I mean by that. Conjugality, in the case of complex numbers, involves a cross-multiplicative translation function to get complex two-component numbers back into linear space for computation. And if you don't understand what I said, I can't go into it now. But complexity is two-componency on the plane with an altered vertical metric. Now, what I've discovered is conjugacy that's rational, so that it actually conjugates both axes into a two-component number that parameterizes circular space. And that's so simple to say that it's actually quite a challenge for anyone to accept, I would assume, for the simple reason you have to ask the question, why has nobody noticed this before? If it's staring us in the face, as really my discovery proves, why didn't anybody see it before? So you see, this raises a question, am I wrong? Well, no, I'm not wrong. So I want to explain why it's obvious that I can't be wrong. There's no wrongness involved. It's a simple observation of how numbers work. So what is this? What is the divisor where someone who doesn't know what I discovered would not see it? But what have I discovered that makes this visible? That would be a genuine discovery. Well, it's two-componency rational space. Now, that two-componency refers to mathematics. What is it geometrically? It's the conjugation of the vertical and horizontal aspect. Why has that been so elusive, since it's obvious that's what you would want to do? You would want a two-component number system. Well, there are several hurdles. You would have to say either psychological or just mathematical or rational. Why you can't do that. And I've actually solved that mystery. So the true answer that I want to give you, what is conjugality? It's a mathematical term for cross-multiplication, which is common both to the proportional number system on reciprocity. Reciprocal 1/2 times 2 over 1, those are reciprocal numbers, they multiply to 1. Well, that defines a new number system. But does it have a geometric interpretation? That's the key. It's orthogonality, but not in linear space. It's orthogonality in spheric space. Now, for more information on that, I'm going to have a compilation of my previous lectures that summarize all this in, I believe, perfectly adequate form. And the reason I think it never got noticed, in part, is due to the fact that I introduced it too early. This is a discovery vector, is turned into a multiple discovery vector. Even the geometry is, in my own research, being expanded to new horizons of explication of physics, which is what we want. All right, so the true definition of conjugality is that it's the mathematical formulation of spheric orthogonality. I hope that helps. This is Anagalactic bringing you the secret of the universe. We're getting to quantum gravity and the rationalization of dual infinity. This will give us the quantum of gravity and the solution to the collapse of the wave function, which Paul Dirac said, and he's not alone. That's the only question that needs to be answered. If you want the unified field solution, which I've got, that's how to get it. I did. We'll be right back.